What if Albert Einstein was never born? Not just forgotten, but completely missing from history. No wild-haired genius becoming the face of science itself. At first, it sounds like one person disappearing from a very crowded world. And that raises an obvious question. Would it really matter? After all, science is not built by one person. It is a long relay race. Every discovery passes through hundreds of hands. One scientist asks a question. Another improves the answer. Someone else turns the answer into a machine, a weapon, a medicine, a satellite, or a phone. So maybe if Einstein had never existed, someone else would have figured it all out. Maybe the same discoveries would have arrived anyway. Maybe history would barely notice. But then again, Einstein was not just another scientist adding one brick to the wall of knowledge. He moved the wall. And in this other timeline, the wall stays where it was. The chalkboard is still there. The questions are still there. Light still moves at the same speed. Matter and energy still follow the same hidden rules. The universe does not change, but our understanding of it does. And that one missing person creates a crack in the timeline. The first major change begins in 1905. In our timeline, 1905 became Einstein's miracle year. He was not working in some grand laboratory. He was not standing in front of a giant machine with sparks flying around him. He was a young patent clerk in Switzerland, doing ordinary work during the day, while quietly thinking about extraordinary things. And then, in a single year, he published ideas that helped reshape modern physics. He wrote about light behaving like packets of energy. He helped explain Brownian motion, giving powerful evidence that atoms were real. He introduced special relativity, changing how scientists understood space, time, and motion, and he gave the world the most famous equation in science, E equals mc squared. But in this timeline, that patent office chair is empty. The papers are never written by Einstein. The year 1905 passes quietly. No miracle year, no sudden burst of insight. No one person connecting light, time, energy, mass, atoms, and motion in a way that makes the world stop and reconsider reality. Scientists are still working. They are still measuring light. They are still debating atoms. They are still arguing about electricity, magnetism, and motion. But without Einstein, the breakthroughs become scattered. Instead of one miracle year, the world gets decades of confusion, partial answers, and missed connections. Science does not stop, but it slows down. And at first, most people do not notice. Trains still run. Factories still smoke. Apples still fall from trees. Ships still cross oceans. And without Einstein, scientists keep trying to force the universe into older explanations. They patch old formulas. They invent exceptions. They build complicated workarounds. And one of the earliest clues comes from a tiny planet near the Sun, Mercury. For years, astronomers had known that Mercury's orbit was slightly strange. Newton's gravity explained almost everything about its motion. Almost, but not all of it. There was a tiny mismatch, a little wobble, a clue written in the movement of a planet. In our timeline, Einstein's general theory of relativity helped explain that mystery. The Sun was not simply pulling Mercury like a rope. The Sun was bending the geometry of space-time, and Mercury was moving through that curved shape. But in this other timeline, that explanation arrives much later. Astronomers stare through telescopes, professors argue in lecture halls, students raise their hands and ask, why is Mercury weird? Some scientists suggest there must be another hidden planet. Others think the measurements are wrong. Others try to adjust the math. The universe is giving them a message, but without Einstein, humanity takes longer to read it. The planets keep moving exactly as they always have. Human understanding is the thing falling behind. Then comes the equation that everyone knows, even if they do not fully understand it. E equals mc squared. In our timeline, this equation revealed something astonishing. Mass and energy are deeply connected. Matter is not just solid stuff sitting in the universe. It is a kind of locked away energy. A tiny amount of matter can represent an enormous amount of power. Einstein did not create nuclear physics by himself. Many scientists contributed to what came next. But his equation gave the world a clear doorway into understanding why atoms could release such tremendous energy. In this alternate timeline, that doorway does not open as early. The relationship between mass and energy is still true. Nature has not changed. The atom still holds its secrets, but the explanation arrives later. Maybe another scientist discovers a similar idea. Maybe several scientists each find part of it. Maybe the truth appears slowly, spread across journals, conferences, arguments, and forgotten papers. The atomic age does not vanish, but it arrives late. Governments fund research more slowly. Textbooks remain incomplete for longer. Scientists argue over theories that, in our timeline, Einstein helped clarify. In this world, the light bulb still turns on, but first it flickers. Now jump forward. You open a map on your phone. You expect the little blue dot to know where you are. You expect it to follow you down the street, tell you where to turn, warn you about traffic, and guide you to the front door of a building you have never seen before. It feels simple, almost magical. But behind that little blue dot is one of the most delicate timing systems humans have ever built. GPS depends on satellites carrying incredibly precise clocks. And those clocks do not experience time exactly the same way clocks do on Earth. Because of speed and gravity, satellite clocks drift. To keep GPS accurate, engineers need corrections from special and general relativity. In our timeline, relativity is not just some strange idea in a physics book, it is part of the invisible math helping your phone know which turn to take. But in the other timeline, if relativity is delayed, GPS arrives late, works poorly, or takes years of trial and error before engineers understand why the system keeps drifting. A driver follows the arrow and ends up on the wrong street. A delivery truck misses its destination. A ship loses precision crossing the ocean. Planes need more manual navigation. Emergency services waste precious minutes. The world still moves. But it moves with less certainty. Modern logistics become slower and more fragile. In our timeline, the global economy depends on synchronized time. Containers move through ports, planes cross continents, trucks deliver food, medicine, electronics, and machinery in carefully timed sequences. But in the other timeline, the system is clumsier. Ships rely more on older navigation tools. Ports depend on more paper records. Deliveries take longer. Warehouses hold more inventory because no one fully trusts the timing. A package from across the ocean does not feel instant. It feels like a journey. Even communication changes. In our world, so much of modern life depends on technologies that came from deeper understandings of light, atoms, and quantum behavior. Einstein did not create the internet, digital cameras, lasers, or solar panels by himself, but his work helped push open doors that later scientists and engineers walked through. Without him, some of those doors open later. The internet may still exist, computers may still exist, phones may still exist, but the timeline is stretched. Some technologies arrive years late. Others arrive bulkier, more expensive, less reliable, and slower to spread. A family does not store thousands of photos in the cloud. They still keep albums. Space exploration also feels the delay. Rockets can still be built without Einstein. Engineers still understand thrust, fuel, pressure, orbits, and basic mechanics. The dream of space does not disappear. Humans still look up at the moon and wonder. But modern space science depends on extremely precise physics. Relativity helps with satellite timing, deep space navigation, black holes, gravitational lensing, high-energy astrophysics, and the behavior of objects moving at extreme speeds. Without Einstein's framework, scientists still reach upward, but they do it with more uncertainty. More missions fail, more calculations need correction, more strange observations sit unexplained. The alternate timeline still dreams of rockets, planets, and stars, but it takes longer to understand the universe it is trying to reach. And by the time we reach the modern era, the world is not completely unrecognizable. That is the important part. This is not a world where humanity is stuck in caves. People still drive cars, cities still grow, medicine still advances, computers still appear, other scientists still make great discoveries. Einstein did not single-handedly invent the modern world, but without him, many scientific paths become slower and less direct. Physics becomes more fragmented. Nuclear science develops later. GPS takes longer to become reliable. Space exploration becomes more uncertain. Technologies connected to light, timing, atoms, and high-energy physics arrive with more confusion and delay. Because science is never built by one person. Einstein stood on the work of others. Others challenged him. Others proved, corrected, expanded, and applied his ideas. If he had never been born, the universe would not change. Light would still travel. Gravity would still bend space-time. Matter and energy would still be connected. Satellites would still need time corrections. Atoms would still hold enormous power. Nature does not care whether humans understand it. But yes, one person can still change everything. Not by creating the laws of the universe, but by seeing them sooner. By connecting ideas that others saw separately. By asking a strange question at the right moment. By giving the world a language for something it was not ready to describe. That is the real power of this what if. It reminds us that history is not only shaped by armies, presidents, empires, and wars. Sometimes it turns on a quiet person sitting alone with a question no one else thinks to ask. What would it feel like to ride beside a beam of light? In our timeline, that question helped reshape reality. In the other timeline, the question waits. The chalkboard stays messy, the clocks drift, the maps are less certain, the rockets rise more slowly. The future still comes, but the world waits longer to understand it.